6.1, solving systems by graphing right here. Okay, to solve this by graphing, put this into our TI-83 or 84s, we need to solve for y. So I'm going to subtract EX from both sides, and we'll get pi y equals negative EX minus 10. Then I'll divide both sides by pi, and I'll get y equals negative EX minus 10 all over pi. Okay. Over here I'm going to solve for y again. We have square root of 2x minus square root of 3y equals 10. I subtract the square root of 2x from both sides. We get negative square root of 3y equals negative square root of 2x plus 10. And then we'll divide everything by negative square root of 3. So we have y equals negative square root of 2x plus 10, all divided by negative square root of 3. Okay. Now we're going to put this in as y1 and this is y2 into our calculators. Now, because our numerator has more objects in it, we're going to have to put an open parentheses, then the negative key, then the e, second function of think division, then x button, minus 10, close parenthesis, the division, and then the pi. Here, it'll be y2 equals, open parenthesis, negative square root of 2, x plus 10, close parenthesis, the division button, the negative button, the square root button, and then 3. Now, note that the square roots will require parentheses, so you will have open parenthesis 2, close parenthesis here, and here you will have open parenthesis 3, close parenthesis for your root. Alright, once we put both those graphs into the calculator, we're going to end up with a solution that is x is 1.454 and y will be negative 4.52, and that'll be the solution of this system. Next, we want to tell what type of systems these are. In order to tell what kind of types of systems they are, I want to solve, make sure everything's in the form of y equals mx plus b, and then we can compare the equations in the system. So for this one, I'm going to subtract 4x from both sides and get negative 6y equals negative 4x plus 12. Then from there, I'm going to divide all terms by negative 6. As a result, I'll get y equals positive 2/3 x minus 2. Now, you'll notice here when we compare, they both have the same slopes, but they have different intercepts. This means that these two lines are going to be parallel to one another. And parallel lines would be inconsistent. Okay. They would have to touch in order to be consistent. And since there are no solutions, it's independent. To be dependent, they would have to have infinite solutions. And here they have no solutions. So inconsistent and independent. Okay, next one. Alright, this is already in the slope-intercept form. We want to put this in the slope-intercept form by subtracting 2x from both sides, and we'll get negative 3y equals negative 2x plus 6. And we'll divide now each term by negative 3. And we get y equals positive 2/3 x minus 2. Okay. And here you can see that both lines are the same. So these two equations actually fall right on top of each other. So when you graph one and you graph the other, they fall on top of each other. And so, will these be consistent? Yes. Consistent simply means that they intersect or touch. And they definitely do intersect or touch. So this is consistent. Now, it's also dependent. Dependent is simply the idea that you have infinite solutions, and every point that they meet is a solution, and there are infinite amount of points at which they meet. So this system is consistent and dependent. Next, number 3. I want to solve for y again. So we have 2y equals negative 6x minus 16, and we'll divide each term by 2. And I end up with y equals negative 3x minus 8. Anytime that you can demonstrate that the slopes are different, anytime you can demonstrate that the slopes are different, you know that these lines will eventually intersect. You know that these lines will eventually intersect. Therefore, because they intersect, they will be consistent. Again, consistent simply is the idea that you have some intersection between the two lines. And when they do intersect, you only get one solution. So this will be independent. Okay, to be dependent, you would have infinite solutions, and we only have one here. So this is not dependent, or should I say independent.